Welcome to my Commander X16 programming tutorial series on the Retro Lemur channel. I go by the name Mooing Lemur, and this is an intro video in the series where we will go through the steps needed to prepare a Linux system for Commander X16 assembly language development. You can check the description for links to the other intro videos where I go over setting up the development environment for other operating systems. Links to playlists for the entire tutorial series can also be found in the description, and I recommend bookmarking one of those playlists. In this video, we will be going over the following. We'll install Git, Make, and GCC. I'm using Ubuntu 24.04 for this demonstration, and like most other popular distributions, it is done via the apt command. We'll then download, build, and install CC65 from source. CC65 is a compiler, assembler, and linker for the 6502 family of computers, and in this tutorial series, we'll be using its assembler to build Commander X16 programs. While some Linux distributions, including Ubuntu, have a version of CC65 in their package repository, it is almost certainly old and without all of the updates for the Commander X16 target. Next, we'll install Visual Studio Code. I use it as my main development editor, but for the purposes of this tutorial, I won't be using any of VS Code's development integration beyond the context highlighting and autocomplete. If you prefer to use a different editor, you can skip over this part and use your own. It won't prevent you from being able to follow the tutorials. We'll need the Commander X16 emulator. Chances are that if you're ready to write code for the Commander X16, you already have it, but I'll include it for completeness. And finally, we'll write a quick Hello World program to make sure everything is working. URLs used in this video will be included in the description. Also, don't be shy if you need to pause the video or rewind to rehear an explanation. Some parts of the tutorial will likely go by quickly. First, open the terminal and install the Git, Make, and GCC packages. On Ubuntu and related Linux distributions, it should look like this. We are calling it via sudo since it's a system-wide change. Next, we're going to pull down the CC65 source via Git, which will be placed in the directory called CC65 in our home directory. Next, cd into the directory. There is a makefile here, so all we should need to do is to type make, but we're going to speed it up by using multiple jobs. I'm using the bash time command so that it will tell us how long it took at the end. I'm using -J8 for 8 parallel jobs. Then finally, I'm telling the build the prefix of where the files will eventually be installed to, which is important to having the CC65 toolset know where all of the support files will live at runtime. The whole command looks like this, and we can now run it. On a modern computer, this shouldn't take very long, even though there are thousands of lines of output. Now to install, we need to call it with sudo since our install path is system-wide, and then we're going to type make install and then give the prefix again. Next, we're going to install Visual Studio Code. The easiest way to install this on Ubuntu is to use the snap. It could be installed via Ubuntu's App Center, but we'll do it from the command line instead, since this method translates to other Linux distributions that support snaps. This is the command to install the VS Code snap. Once it's complete, we can open VS Code. I do it by pressing the Windows key and typing VS, which is enough to bring it up to the top of the search results. When writing code in any programming language, it is always nice for the editor to highlight the language's syntax. By default, Visual Studio Code does not have knowledge about the syntax of 65CO2 assembly, so I recommend installing an extension that provides it. I use this one called CA65 Macro Assembler Language Support. And for the final piece of software that we need, I am downloading the Commander X16 emulator. At the time of recording this part of the tutorial, the latest version available is R48, but I recommend always grabbing the most recent release available for your platform. The Commander X16's ROM and emulator are now mature enough that there should be very few changes in the future which would make any part of this tutorial series obsolete or out of date. But if it does happen, or if there's an obvious mistake that is discovered later, I intend to publish an updated video to replace any video which contains out-of-date or mistaken information. The old video will be made unlisted and removed from playlists, and the new video will take its place. For convenience, I'm extracting the X16 emulator to a folder in our home directory. And now back to VS Code. We're going to do one last thing before concluding this episode of the tutorial, and that is to write, assemble, and run a Hello World program in assembly. In VS Code, we're going to create and open a folder in our home directory called Hello World, in which we are going to put our source code file. When doing this sort of development, it is a good idea to avoid putting spaces in directory and file names. We're going to create a file called main.s. And here we're going to write our source code. The CC65 suite supports the Commander X16 directly. To take advantage of what it knows about the memory layout and how to assemble a PRG file, our source code needs these 4 segments declared. All you need to know for now is that the assembler places a basic program at the beginning of the file, then passes control to the beginning of the startup segment. Conventionally, the bulk of the program is placed in the code segment. Because CC65 and its assembler CA65 by default convert strings from ASCII to PETSCII, I nearly always include the ASCII_charmap.inc file to prevent these conversions. Therefore, string constants like the one I am typing in now are stored in the data exactly as typed. Without this, uppercase ASCII is treated as shifted PETSCII, which will not display the way we want in uppercase PETSCII graphics mode. With this include, we are telling the assembler to leave strings in the source as is. As an aside, one may argue that constants like our Hello World string belong in the data or RO data segments, but it will still work fine being lumped in with our code. In this example, we placed our string constant before our code, therefore we have to jump over it to our start label. This is what the JMP instruction is doing in the startup segment. In this example, we're using one kernel call, chrout. Normally, we use an include file with all of the API call names, but for this simple program, we'll just define the one we need as a constant. Don't worry if you don't quite follow what is happening here in the assembly code. This is just an exercise to verify that everything is working as expected at this stage. After pressing Ctrl S to save, we go back to our terminal, showing a listing of our home directory. We can see the new directory for our Hello World project. Inside is the one source file. To assemble and link the project in one step, we can call CL65 as shown here. We are telling CL65 to build with the Commander X16 target, and then giving a list of source files, of which there is only one. Then with -O, we are specifying the PRG file name that we want it to create. Absent any error messages, you can likely assume that CL65 succeeded. We can start the emulator with the -PRG option to have it load our assembled project, and then we can pass the -run option to automatically run it. Oops, there is one more thing that the emulator needs, and that is to have libsdl2 installed. The easiest way to get it is to install libsdl2-dev like this. Hitting up arrow to recall our previous command, let's try again. Here we go, the emulator runs, and our Hello World program works just as expected. Don't worry about the error message here. This is just an artifact of the emulator being run in a VM not set up for graphics acceleration. The emulator works just fine without it. This concludes the intro episode, which hopefully has helped you set up the necessary software to get started with assembly language development for the Commander X16 on your Linux system. Again, check the description for links that were used in this tutorial, as well as links to YouTube playlists for the rest of this tutorial series. Thank you for watching.